Hey there, Math Moment Makers. It's Kyle here again from MakeMathMoments.com. And I wanted to give you another sneak peek into a classroom. Again, recording the screen, kind of showing some of the prompts, some of the thinking that we might use in a problem-based lesson. But before we do, I'm hoping that if you're watching this, that you're either on Facebook or you're on YouTube, and we want to make sure that you are subscribing, because that is something that you need to do regardless of the platform you're on, to ensure that you are making sure that you're notified when we go live or when we release a new video. So we try to keep them as short as possible. Some of these classroom sneak peeks are going to be a little longer, but I have tried to chop out a lot of the blank time or the quiet time, so the working time. So do keep that in mind, but we try to take you through so that you have an understanding of what's going on. Now, before we dive in, keep in mind we do have a 3-part framework guidebook that you might want to check out at makemathmoments.com/framework. You could just head to makemathmoments.com and that will do the trick for you, because there are links around the site for you to go check that out. In order to have a good understanding, a good sense of how we're running and leading these problem-based lessons, you'll want to go check out that guidebook. So before we get started, the task, just to give you a little bit of context here, we are in a virtual learning classroom, and we are learning about and introducing the idea of pi. So we are trying to emerge this idea through the relationship between the circumference and the diameter. Now, I remember as a student and as a teacher basically telling students that this is what it is, but to be honest, I never had a visual. I never had a real conceptual understanding of why that is. Like, why does this relationship work? So doing that concretely or visually can be really helpful with that. So we're going to do it through a problem-based lesson. Now, while you may be familiar with our problem-based units that we have available here, we have many and more are on the way. Keep in mind that we also, John and myself, also have our own, we'll call them original websites. Mine is tapintoteenminds.com, and on that site I have all kinds of tasks. Now, they haven't been updated, all of them haven't been updated to be fitting in the 3-part framework, but as we do these updates, we bring them over to the Make Math Moments site. We're a little more explicit about the learning goals, the learning intention, and we also try to be more helpful with the teacher moves, some of the student solutions that you might see, and so forth, and inside the teacher section. So for now, though, these are great tasks, but you may have to do a little bit of modifying when you look at how they run independently here, because when we wrote these posts, we didn't know or understand how to lead a problem-based lesson like we do now. So it is our intent to take all of these tasks, build them out into units, and ensure that we give you more guidance as a teacher so that you know you have the teacher moves that you need in order to run these without a hitch. So without further ado, the task we're going to use today is tile circle. It is on tapintoteenminds.com. I will put the link right into the notes. An easy way to get here is just by Googling tile circle math. That'll get you there. Or you could just go tap into Teen Minds circles. That will get you there as well on Google, or just head straight to my website and you can use the little search button and just type in tile circle or circles and it will appear for you. So without further ado, we're going to dive into this particular task. I'll throw some of the links into comments and in the description of the video. And I hope you enjoy this sneak peek with a grade 7 virtual learning classroom. Make sure you let us know in the comments, what was your big takeaway? What did you notice? What did you wonder? What did you like? What are you maybe grappling with that you're not feeling good about? Throw them in there. I'll do my best, and John will do their best to respond to those comments. All right, we'll see you on the other side of the sneak peek. So I want to get us started as we did last time, if there's any brave souls out there. And we're going to engage in another notice and wonder. And this time I'm hoping there was a lot of participation last time. But what I'd love is to actually get everybody sharing at least one thing they notice and at least one thing they wonder. And you're not limited to just one of each. You can add as many as you'd like. But at minimum, we want to share at least one of each. And I would encourage you to raise those new digital emojis that you have if you'd like to share with your mic. And as we're watching this short little clip, both misses can actually select some friends to share verbally. It's always great to kind of hear some of these ideas as we're playing. Is everybody cool with that? Is everyone set and ready to go? All right, here we go. Let's have a quick look at this. The sound is just ambient noise, so don't worry about sound. And if it's choppy, no sweats. All right, my friends, we're having a peek here. What do you notice? What do you wonder? Do we have any digital hands raised that are willing to turn their mic on and share, my friends? No sweat. You could still notice a lot of things. So it's like you've noticed it's like a school. Why record? I'm just going to make my own little table. You folks could be creating your own little notice and wonder table as well. Ooh, why are they recording the rug? What? So it's almost like another check for that one. Like, why record? Like, what's going on here? Awesome stuff. Anything coming in? Anything else coming in the chat? I see a couple digital hands still up, but I don't know if they've shared already. Okay, notice it isn't a public school, and that was Dryden, I heard. And I'm wondering for a second here. I'm hearing this, and actually Walkerville is a public high school, but maybe like it's not an elementary school, maybe something like that. So it's interesting. So some of our noticing and wondering is a little different, maybe based on what part of the county you're coming from. Some people might be more familiar with that building. I'm actually going to go ahead and confirm that yes, that is Walkerville High School from the public board. So that would be where some of our friends from Begley might attend school, and Hugh Beaton, and a number of schools out in that area. Prince Edward. Fantastic. Let's keep this rolling here, friends. Any others? What do we have? Yeah, and I wonder, is it like a makeup powderer? Like almost like one of those things that you actually like put some makeup on? Bronzer. Interesting. Love it. Love it. Awesome. Okay, let's see if we can get one or two more. Let's see. Rug. So we have some people questioning here. They're like, wait a second. Like someone said it's a rug, but can we confirm it's a rug or not? I don't know. It's kind of hard when you're in like the 2D world, right? Of just photos and video. Super cool. We've got tons of great ones. If any others come, feel free to interrupt and I'll add them to the list here. So I think we've confirmed a few things here. First off, like Dryden was thinking like it didn't look like a school that he was familiar with. But then we heard someone else. I don't know who it was, Miss. Did you catch a name for that? Who said, why are you at Walkerville? Sebastian. So Sebastian was saying like, no, actually, this is Walkerville. And I can confirm that yes, it is Walkerville High School, which is in the kind of the east end of Windsor. I want to answer a couple other things, like why record the school? That one I can confirm. That actually was when I was walking in, I was going into the school and I was going to be doing an activity very similar to an activity we're going to do today. I'm not going to tell you what it is yet. We'll explore it in just a second. But I thought, you know what? This could be a really good visual for us to engage in. So I just took it on my phone and then I shared it with that class a little bit later. So I'm hoping to do the same with you here today. A few people said, like, why record the rug? Why are we doing this? And then we had a question about, is it not a rug? So I've got to sort of address that because, like, one of these is obviously accurate and one is not. And I'm actually going to tell you that it is not a rug, okay? It is actually a tile, like, I'll call it like a bit of a, you know, what would you call that? Like a mosaic in a way. If you look at it a little bit more closely, you'll notice that it's actually like something in the floor. It's actually like a part of the floor. And if you look at this image here, it looks like it's a rug on the floor, but it's actually in the ground. It's a really beautiful little compliment to the entrance of Walkerville High School. So I'm looking at this thing and I'm thinking, like, what the heck are we gonna do with it? Someone asked as well, they said, I wonder if we're gonna make predictions. You know that when I show up, I've only been in your class one time so far, but last time we made you do a lot of estimating, right? And getting you thinking about what might happen, where might we go with this? And we're gonna do the same thing again here today. So you are right. Miss, it looks like you had a hand gesture. Is someone saying something amazing? I'm really gonna struggle on the spelling. Terrazzo? Yeah, tell us more about that. I know it is something to do with flooring, but I actually couldn't identify myself where or what it is. Oh, interesting. So it's like some sort of material, like it's like a type of material, maybe like a rock or stone, or I'm not really sure, but that's something new I just learned from that experience. That has never come up in all my time using this particular visual. So that's really cool. That's new for me to add to my little repertoire here. And actually, when I look a little closer, I can kind of see, it's like, I think maybe describing like almost like the edge, like that. It's almost like it's kind of around the edge of that tile, which is super cool. And actually, you know what? I think I would love to do some exploring. I wish I could answer the terrazzo question. I'm going to look into that. I'm going to see if someone can help confirm or deny that for us. But I don't know that one. Chips of marble or granite. I love it. So we're going to have to, we're going to have to look into that. Like, it looks like there's like chips all in here. So that's interesting. I love it. And you know what? So we've answered a lot of these questions, which is awesome. One we haven't, which came in late, was about those small tiles on the kind of like on the outside of that circle. And actually, I wonder if we spend a little bit of time on that right now. What I'd like you to do, and again, going back to this wonder over here, we are going to make an estimate. I would love for you to estimate how many of these small tiles do you think it'll take to wrap around the entire circle. Now, I've strategically zoomed in here, so you can't actually like count this one to one, but I wonder if there's any folks out there who might be able to do some estimating. So before you post, if you already did, it's my fault. I should have already framed this, but before you post, I'm gonna have you think about 3 numbers, okay? I think we did this last time, okay? We're gonna have you think about a number that you feel is like too low. Like it's almost like if I say this number, I can almost guarantee it's not going to be that number. We're also going to get you to think about it a little more risky though. Like 1, I know it's more than 1. I would even argue most of you would say it's more than 20, because I'm almost thinking they're probably more than 20 right up on the screen right now. I want you to think of a number that you feel is too low, but not silly low, like 0 or 1 or even like 5. Like, be risky about it. And I want you to also think about a number that's too high. And you're gonna think about a number you're like, well, I know a million's too high. I know that like 5,000's probably too high. Like, can you be risky about that? And then once you've had that, we want you to think about like, so what would be a reasonable estimate? And we're gonna have you share those all at once, okay? So you can get yourself all set up. You can put your first number as your low number, Your second number could be maybe your actual estimate, and your third number is that high number to kind of set us a little bit of a range. And when miss, count to 3, we'll have you submit it. Some of you may already be doing that, and that's totally fine. No sweat. But we're going to see if we can kind of make a nice waterfall in the chat here. What do you say, Miss and Miss? Are you ready to queue them up for their estimates? Maybe let's give them maybe 30 seconds, 45 seconds to think this through. Yeah, thinking about what would be too low. What do you think would be too big? And all right, we're gonna give you a little bit more time to get yourself ready, and then we'll let Miss and Miss decide here when to count it in. Okay, I'm gonna toss 150 right here. I heard 150. Give me some others. Got it. All right, so I'm seeing lots in the chat, which is great. Lots of lows and highs, which are kind of way spread out. Now, I'm wondering, can you read off some of the best estimates out there? And I see a hand just went on, so maybe we'll let that person share if they're up for it. Flip on your mic and tell us. Oh, so you saw 33 in like, almost like, if I drew it, it was kind of like a little section like that. And you were like, if that's 33, I'm wondering, what made you think 175? Like, what was your thinking there? Did you say like, I think there's a certain number of these that'll make a circle? Or like, what was your thoughts there? Got it. So you kind of like estimated different sections a little bit. You were like, well, the side parts would probably be around 50 and 50. The top and the bottom around 30, and then you said, that's going to work out to around 175, thinking that you're estimating anyway, right? So it's not like we have to add these ones and make it exact. I think that would be what, 166 or whatever. So you're like, I'll go a little higher than that. That seems really reasonable to me. Awesome. Do we have any others out there that we can add to our number line here? 120, so that'd probably be like somewhere around here. I'm not going to do this perfectly, but kind of looking like 30, and this is like, that's like 25. It's pretty close. Maybe it should have been a little bit further that way. What else? You said 136 and 137, so I'll just put 136 there. And lots in here. Interesting. I'm wondering, anyone who is around 136 or 137, I'm wondering if they would share. Like, why did we get so many around here? I'm wondering if maybe they had a similar thought or how they came about that, if it was just sort of random. Anyone willing to share? Oh, interesting. So are you telling me that you feel like this section right here, I don't know if you can see my mouse very well, but that this section is like 1/4 of the whole circle? Is that sort of like your thinking? Super cool. So like you were saying, okay, well, if I counted and there were 34 tiles, and that represents like 34 tiles is 1/4 of the circle, you were like, well, I'm just going to scale it by 4, and you ended up with around 136, was it? Super cool. Put a little dot there, like an approximately 136 or so. Super cool. Interesting. I'm wondering though, like some others may have come up with different numbers if they thought like maybe this section wasn't actually 1/4 of the circle. Like it could have been like maybe like 1/3 of the circle or 1/5 of the circle, or who knows, right? So that's really going to alter some of our estimates here. I'm wondering, and maybe Miss can help me with this. Were there any best guesses that were lower than 120? Because I kind of want to set ourselves a little range here to give us kind of like a nice little playground to work with here. What do you think? Okay, so I'm going to put that like somewhere here. I know my scale is off, okay? My scale is definitely off when I look at these numbers, but that seems like kind of like the low end of our best guesses. How about high end of our best guesses? Like, was there anybody who was above 175? Oh, a 355, so over here. So that's going to stretch us a little bit. I'm going to stretch that out. So I just want to give you, we had a couple more even further. So this is a pretty wide range. Interesting. I'm wondering if we're, like, estimating is great. I love when I start to see things cluster up, because that always gives me at least a thought that, like, some people are kind of on the same page or on the same track, and it makes you think of, I don't know, I wonder if it's going to kind of be in that zone or if it's going to be maybe none of us could predict it. Who knows? But what I will do though is I'd like to share a little bit more information with you, okay? So what I'm going to do is I'm actually going to give you a little bit of information, and then what I'm going to have you do is I'm going to have you update your estimate, but we're going to try to hold back from sharing it yet. We want everyone to have an opportunity to think this through before, and then we will once again have you hit enter to update your estimate. Maybe you want to keep your estimate the same after this. It's totally up to you, but I'm going to encourage you to take this information and try to think of how this might help you make your estimate more precise. Okay, are you ready for this? Are you ready? Some people? All right, we got some people. Oh, I want to make sure they were there. Holy smokes. Sometimes I get cut off on the internet and I'm talking for a long time and then I realize I just taught a whole lesson to no one. That's never fun. So here we go. I'm going to give you this, okay? Some people are like, well, why don't you just count out that section along the top and that'll be helpful. That could work. But what I'd like to give you instead is I'd like to actually help you with the measurement across this circle. Now, some of you may or may not know what this is called, but when we go all the way across the circle, feel free in the chat if you want to let us know if you know what the name is when you measure from one side of the circle all the way across through the center. It has a really special name, and I'm wondering if anybody out there has heard this name before. Ooh, what are you thinking? What are you thinking? The diameter. Nicely done. So this section all the way across, it's like, I don't know why this is going so slow, but it was like I was actually like tiling the floor all the way across. That's how slow that just went. I don't know why my computer is so laggy today, but I will tell you this. With the same sized tiles that we used all the way around the circle, it took 52 of them to get from one side all the way through to the other side, through the center. That is called the diameter, like you told me. And what I'd like you to do is think about this, and I want you to almost in your mind, or maybe you want to draw this out, or maybe you've got some counters nearby. I want you to think about like, how many do you think it would take to get all the way around the circle? I'm going to encourage you not to just count all the way around either. You could do that, and you know, in maybe 10 or 15 minutes, you'll know the answer. But I want you to visualize this, like if you were to take those tiles and you were to use them to get around the circle, like I'm wondering about how many. I'm going to give you another 30 seconds before we count it off, and then we update our estimates in the chat. You just have to put one number. It's your new updated estimate. Miss and Miss, I'm going to let you do the honors, and when you're ready, we'll rock and roll. Updated. Okay, and I'm going to use a special color for these updates, and I'm wondering if like that's going to make things a little bit, like I wonder if this is going to tighten up or if that's going to actually spread out. I got a funny feeling, I don't know about you, feel like this range is going to tighten up a little bit. All right, let's start feeding some of these so we can get them down on this number line. What do you think? 156, so somewhere around there. 200, so somewhere around there. 255. So our range looks like it's tightening up. Another 136. Okay, I want to ask a question though. I'm going to bring this back up because here's something kind of crazy. I want you to picture for a second. I know this is just a tile. It's you know, it's on the floor. It's in the atrium, so it's not very big. But like, imagine that you had to walk on this tile, and I'm wondering, would it take me longer to walk straight across the tile? Or would it take me longer to walk all the way around the edge of this tile? Like, so I could walk from here. Let's pretend these are meter sticks. Like, would it take me longer to walk at the same pace from there to there? Or would it be further or less distance to walk all the way around the exterior? So like, picture it's like a circular park. And your buddy's over here, you're right here. You're with two buddies. One buddy decides to go walk this way. The other buddy decides to walk this way. I'm wondering if they're walking at the same pace, who's going to get there first? I'm just curious about that. I want you to think about that for a second. Which distance would you rather walk if it, and like you can imagine, let's pretend they were kilometers, 52 kilometers. Would you rather walk 52 kilometers here, or would you rather walk the number of kilometers here when you just look at it on a map? I don't know. I'm wondering, does that influence anybody's estimates at all? We'll wait on this here. If we have anyone with a brave soul who wants to raise a hand, that would be fantastic. Ooh, interesting. I like that fast. So a straight line's the fastest way to travel. And then I guess the question I'm wondering too, yeah, like if it took me that many tiles to get straight across, to me it feels like it's going to take me longer over here. So I'm wondering, does that influence anybody's estimates? Does anybody want to update these estimates at all? I noticed right here, I'm going to write this down. I noticed a lot of people said 104, which you may or may not have noticed, but if it's 52 tiles to get across, is it only going to take 2 of these in order to get around the entire circle? I don't know. I wonder. Do we have any updates coming in the chat there, Miss and Miss? What do you think? Oh, was that a 104 estimate or was that a different estimate? Really important for us to discuss. Absolutely. I'm so happy that it was brought up because this is the part, and I would say maybe one of the most difficult parts of mathematics is when we take an idea and we go with it, we make some assumptions that might not be the same as somebody else that we're trying to communicate with. So yeah, I'm going to clarify here just to make sure that's clear. So we're trying to figure out like how many of these tiles, it takes 52 to get across. We're looking to figure out how many tiles are around the outside. We're not talking about how many will fill the inside, but that sounds like a really interesting question too. You know me, I love counting stuff. So maybe that's something we can explore a little later. Right now, we're just trying to figure out like how are we going to get this all the way around the outside. Now, I'm wondering if I give you a bit of a visual, like check this out. If I'm going to like make them green so it's really easy to see. And I'm actually going to take each of these tiles and I'm very quickly, I'm not going to do it as slowly as I did last time. Very quickly, I'm going to actually take all of these and I'm going to put them around the outside until I run out. I only have 52 tiles here, okay? So I'm going to do this and I'm wondering, as soon as you want to update your estimate, you can go ahead and update your estimate in the chat, okay? I'm going to go ahead right here. If you want to think about that, feel free. You don't have to wait for us. You can just press enter when you're ready to update your estimate. I have a funny feeling that our range might tighten up here a little bit when you see that. Like, I don't know about you, 104 is 2 52s. I don't know if that's going to make it all the way around. I want to hear some new estimates. I'm going to use yet another color to help us out here. Ooh, so like somewhere in this range over here, another one over here. Super cool. I am going to mark this down, but I want to keep this up for people to see. Okay, I've got one there. What else do we have? Oh, oh my gosh, look at us start. Look at this. Starting to really cluster up here. What else do we have? Just a part. Yeah. But look at this range. Look at how it's really tightening up. I love that. Friends, I think most of us would say that if you pick something in this kind of neighborhood, you're going to feel pretty good about your estimate, I'm guessing. If you're way over here, I'm guessing you're not feeling so good anymore. Maybe even if you were here, I think we all almost confirmed that 104 is not going to be enough when we looked at this. Although initially that was an amazing estimate, right? Before you saw this, it's like, oh yeah, it's going to take my friend longer to walk around this circle than to walk straight across. So I love that comment about traveling in a straight line is going to get you there a lot sooner. So super cool. I love it. Feel free to keep updating your estimates as we go here. I'm going to show you one more set of 52 tiles, and I'm going to place them right here. And I wonder, keep those estimates rolling. Let's keep them rolling. Let's think about this here. Yeah, that is also 52. Those pink tiles, I took another 52. I placed them right here. And whoops, I didn't place them right there. My computer is really slow today. Like I want it to show something, but it's not showing. So we're just going to go with it for now. But yes, those pink tiles are 52 in total. Do we have any new estimates? Anyone want to share? Ooh, lots in the 150. It's like we're really tightening up here. Holy smokes. Holy smokes. We had a lot of people hanging out in this range here. Look at that. We're like zoning in. Like this is what mathematics does for us, my friends. It helps you go from like kind of more of a, we'll say a vague estimate to like a more precise answer. Like we're almost getting close here. I see a hand up. Is anybody willing to like share verbally what they're thinking? Like what's happening here? Super cool. I love how you said it. It appears, and that is such a great word because it's like, it's hard to know for sure, but it appears like 3 groups of 52 tiles are going to make us all the way around. And I love your thinking. You're like, well, that means I need 3 groups of 52 tiles. And you had mentioned that's going to be like, I don't know about you, but I don't know the answer to this. So I'm going to do, I know how to count by 50s, 50, 100, 150. So that's 150 plus 2, 4, 6. So there's 3 groups of 2, 4, 6. Oh my gosh, 156. I saw a lot of you were saying 156 earlier. So it's almost like you told me that, like it's almost like you were telling me that this is what you were thinking, which I thought was really cool. But I'm so happy someone reiterated it for me. Super cool. I love this. Here's what I'm going to do. I'm going to let you know that you friends have gotten so precise. Let's see. I'm going to take 52 more tiles here. And let's see here if my computer will allow me to do so. I will show you what they look like. Let's see. Is it going to take forever for this to happen? I don't know. Let's see what the computer says. The computer is saying we're going to take a lot longer than it should. It's the spinning wheel of death is on the screen right now, but let's see if it actually does this for us. It's like suspense. Yeah, if there's someone with a hand up, I'd love to hear their thinking. Holy smokes. So someone just sort of helped us come to a conclusion here, which is fantastic. And I want to be completely honest with all of you. I think I mentioned this last time I was in the class, but who knows? All of the different classes I go into, my stories get all mixed up. But I was saying recently to some students that I actually had no idea. And I went to school for mathematics. Like I went into a university program because supposedly I was okay at some mathematics. And what I realized afterwards is I actually didn't understand math very well because I just memorized stuff. I just knew this thing was called pi, but I didn't know where it came from. And what we're seeing here is what we call the relationship of pi, which is the relationship between the circumference of any circle in the known universe, like anyone that's a perfect circle. No matter what you do, if you measure across through the center from edge to edge, you can take 3 and a little bit of that measurement to get all the way around the circle. Like that is so nuts to me. And it's so important that they gave it a special name. And it's exactly what we just heard from our friend. Who was that was speaking, by the way? I can't see the chat. So, oh my gosh, welcome to the class. Day 1 comes in and is like, listen, there's this thing called pi. I know it has something to do with pi. I love pi. Pi is so good. Awesome. I love that. Welcome to the class, day number 1, and you're telling us and you're teaching us about this thing called pi. And I want to be really clear about this. I want everyone to have a real clear visual of this. Basically, we know it's 52 tiles across that circle. If I was to create 3 of these circles and put them next to each other, the distance across plus a little bit, plus that 14% or so, plus that 14 hundredths of the diameter is how many tiles you need to make it around one of the circles. Holy smokeroos. That is crazy to me. I don't know about you friends, but I am feeling awesome. I'm wondering in the chat, is everybody feeling okay about that? Or is there any wonders about that? Or is there anything that's like kind of feeling not so great? What's going on in the chat right now, miss? I love it. New language. we're going to have to definitely keep going with that. So the perimeter, that distance around, has its own name too. They call it the circumference. That's so awesome. I'm so impressed how amazing this group has been. There's been so many awesome ideas and revelations. I'm wondering, I think we might be able to use some of our estimation skills to come up with, I think, maybe some ideas here. I wonder if you were to use what you know here to take some time and work independently to think about how many squares you think it would take to wrap around these two circles. Now, focus just on one first, but then I want you to look at the second one. I want you to think about, like, uh-oh, what happened there? And how can I use what we just learned in order to help us with these two? You don't even have to be exact. I don't want you to use a calculator. One thing that we do know for certain is it takes about 3 distances across the circle to make it all the way around. So I'm wondering if you were able to come up with about how many squares it would take to get all the way around these circles. And I want you to most importantly explain. So don't worry about that 14 hundredths, that extra part. Just give us a roundabout. I want to hear your thinking about that. Is that okay, Miss and Miss, if they were to work on this for a couple minutes? Yeah, I think let's give them a few minutes, maybe even hold back from sharing in the chat if you haven't already. And then we'll come back in just a couple minutes. I'll even shut my camera off. I don't want you to feel like I'm watching you. You know what? Just that first one's great. So what I heard you say, I don't know if you noticed here, I tried to make myself a circle and I used my coffee mug. And then, you know what happened? This little handle got in the way, and then, you know, that sort of happened. So my apologies, you know, it happens. It is what it is. But I want to go back to what you just shared, which I think is fantastic. You basically took, I love this thinking. You like took your thinking from before and you're like, wait a second, it's going to take 3 of these diameters, 3 of these 15 squares in order to get all the way around, plus a little bit. So what I think I heard you say was that it was like 3 groups of 15 squares. And I think you told me that was like 45, but I'm gonna double check because I don't know about you, but I don't know my 15 times tables. Like I have to kind of break it down. So I'm thinking like every 15 is a 10 and a 5. So I'm thinking like 3 of these and 3 of those. So I'm gonna go 10, 20, 30, 35, 40, 45. Okay, so I believe you, 45 squares. And then you said plus a few. How many extra was mentioned? I can't remember. You said it was like a little more. Maybe 1. And again, this is like kind of like, yeah, just an approximate, right? You're like, eh. One thing that I do know for sure, what we had mentioned earlier is that this idea of pi, there's the symbol for pi. It's written pi, P-I, not P-I-E. And basically what it tells us is that the circumference is about 3 14 of the diameter. In other words, it's saying like if I was to look at this, if I was to go 14% of the way or 14 hundredths of the way, that is what that extra change would be. So like I'm just kind of looking with my mind, with my visual sense, and I'm looking at this and going like, I know that that's halfway. I want to get to like 14 hundredths. Holy smokes, like, I don't know, this would be like a 1/4 of the way, maybe like a 1/10 of the way. I want like 10 and a bit. So if this is 15 and that's like 7, I don't know, around 2 squares feels pretty good for me. And actually, if I wanted to, I could double check. Now at this point would be when you'd want to take your calculator out to kind of see how close you were. So I could be like, okay, all right, I know that there's 15 squares. Actually, I want 3 14 hundredth groups of 15 squares. So I'm going to multiply that by 15. Let's check it out. 47 1/10 of the distance around. Holy smokes, I am so impressed by that estimate. 2 squares is so close to what you had. And let's actually look at this exactly. If I just take the 14%, look at this, 14 hundredths, which again is the same as 14 hundredths, and I multiply that by 15, look at that, 2 and a little bit of a square, 2 and 1/10 of a square. 2 squares is such a great approximate. Holy smackaroos, I am so impressed. Miss and Miss, what do you think? Do you think we should maybe have them submit this second one on their thinking, noting that this is the distance just to the center? You're going to have to do a little thinking on that. I'm going to let you kind of frame that because I know we're running out of time here. I just want to make sure that you get to see who heard what today so that you know where you might want to go next. Yep, so we're focusing in on this one over here. Folks might want to draw this out or take a screenshot of it. I'll send you a visual of it. I'll take a screenshot so that you have it and you can send it to your friends. You're absolutely right. And I hope everybody in the room, like I tell students this all the time, like we are all essentially learning how math works together. Because like you said, Miss, like we didn't learn math, like why things worked the way they do. So we're kind of all on this journey together, and it's so awesome to see so many teachers and friends. You folks have 2 amazing teachers who are so dedicated to trying to make sure that you make sense of the math, because if you don't make sense of it, eventually, I always say the wheels fall off, right? And it's like you're driving and then all of a sudden it's like the car stops working and you don't know why and you don't know how to fix it. But if you understand how it works, then everything just kind of follows and you follow along and you feel good about it and you feel confident. So keep up that work and keep on trying, right? I know it's digital learning's hard. So make sure that you put that effort in, and I promise you put that effort in and you engage in the conversations like we had here today, you're going to be doing great and you're going to feel awesome afterwards. Awesome. Well, I know friends are starting to get working on this last consolidation prompt. So I want to say bye to the group just in case you slip off to your break. Before I get a chance, I want to thank you all for welcoming me into your classroom. I know it's kind of odd when somebody just sort of shows up and starts teaching the class. So I'm really having a blast. I'm hoping I get to come back and hang out with you all again. So thanks for being awesome. And I can't wait for both Miss and Miss to share some of your work. I'm really curious to see how you're conceptualizing this idea. We will see you all soon. My pleasure, my pleasure. All right, Math Moment Makers, I hope you enjoyed that sneak peek into a classroom where we were uncovering and sort of emerging this idea of pi. Who knew that you could so concretely, I know it was really visually, right? But concretely, if you're face to face, you can actually concretely do this. And then also if you're digital, if you're online, you can do this visually and encourage students to really engage with this idea of the circumference of the circle related to the diameter of the circle. And that, you know what, no matter what circle, as I mentioned in that class, no matter what circle in the entire universe you grab, it could be this circle right here, regardless of what circle, that 3 and a little bit across that circle through the center is going to get you around the perimeter, which we call the circumference. How awesome is that? If you found that this was helpful, gave you some insight, maybe now you feel confident enough to take the tile circle task with you into the classroom. Remember, it is available for you online, currently on tapintoteenminds.com. But it is being created and converted into a unit, a problem-based unit, all on circles that will also extend to the area of a circle. You'll see in this tile circle task that it actually extends to the area of a circle. That will be coming soon to makemathmoments.com/tasks. Also, make sure that if you haven't yet, wherever you're watching this, hit that subscribe button. Make sure you turn notifications on. And remember, the guidebook is a great way for you to start learning how to build problem-based lessons, or simply to apply the problem-based lessons that you find out there on the internet today, whether it's on tappinateenminds.com or whether it's on makemathmoments.com, wherever you're finding them. Make sure that you check out the guidebook so you get a good understanding of how you can build that curiosity and then fuel sense making and lead and ignite your teacher moves. So until next time, we will see you, and make sure, again, hit that subscribe button, and we'll see you in the next video.